Lesson 3.4 deals with operating with scientific notation. We know how to convert from standard notation to scientific notation and then back again. But sometimes we have to actually do some operations, add, subtract, multiply, or divide within scientific notation. So we're going to look at space. Masses of objects in space are so great that astronomers often need to use scientific notation to describe them. The approximate masses of planets in the solar system are given in the following table. So we go everywhere. We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Unfortunately, Pluto is no longer on our list. Poor Pluto. So we're going to start with division. It says how many times greater, so that should be a clue right there, times greater, that's going to tell us division, is the mass of Jupiter than the mass of Earth. So Jupiter's bigger, so we will go 1.89 times 10 to the 27th, 10 to the 27th, divided by, and we're going to use the fraction bar, 5.97 for Earth times 10 to the 24th power. So when we divide in scientific notation, you really do two parts of division. We're going to take the values, this first factor, and we're going to go ahead and divide those. So we will take the 1.89 and divide it by 5.97. So 1.89 divided by 5.97. And I'll just do it on here for you. 1.89, oops, back up. 1.89 divided by 5.97. And that's a pretty big number. So we're going to go ahead and we will call this 0.317. And then we still have times 10. And now we're going to go ahead and divide with the powers of 10. And over here I put this little hint up for you. You can use the properties of exponents to multiply and divide numbers expressed in scientific notation. So remember, if we have the same base and we're dividing, we subtract the exponents. So 10 to the 27 divided by 10 to the 24th, 27 minus 24 is 3. Now they want our answer in scientific notation. And it's not in scientific notation because remember, in scientific notation this first factor has to be a number between 1 and 9.999999, etc. So to get it there, I have to move the decimal 1 to the right. So we'll call this 3.17 times 10. Well, if I move this, I'm moving it by a power of 10. And if this number becomes larger, 0.317 now is 3.17, then this power has to become smaller as many places as I move it. So I move this 1 to make it right here, so the 3 becomes a 2. Again, I have to compensate. I made this number, this factor larger, so the exponent has to get smaller. And this is in kilograms. So the mass of Jupiter is 3.17 times 10 to the second kilograms larger than the mass of Earth. Next we're going to multiply. It says the mass of the Sun is approximately 3.16 times 10 to the 6 times greater than the mass of Mars. Find the mass of the Sun. So we have to look at Mars. 6.42 times 10 to the 23rd. And the Sun is 3.1 times 10 to the 6th times greater. So when you multiply, again, you can do it in two different parts. We're going to multiply the first factors. So we will take, excuse me, 6.42, maybe if the calculator will work for us. There we go. So 6.42 times 3.1 and that gives us 19.902. So I will go ahead and write that whole number down, 19.902. And then we also take these powers of 10 and multiply. So times 10. Remember, when we're multiplying, we have the same base. We add the exponent. So 23 plus 6 is 29. And again, we have to make sure our answer is in scientific notation. And it's not, because the decimal needs to be right here. 19 is bigger than 9.999. So I'll make this 1.9902 times 10. Oh my goodness. 10. Now this number became smaller, so to compensate I have to make the power bigger. And I only moved it once, so I only add 1. And this is in kilograms again. So the sun is 1.9902 times 10 to the 30th kilograms larger than Mars. That's pretty big, because I would move this decimal 30 places over, so that'd be move it over 4 and then add 26 zeros onto the end. Okay, let's just do a couple more examples. Rhode Island is the smallest state. It has an area of approximately 1.55 times 10 to the 3rd square miles. Alaska is the largest state. The area of Alaska is 4.28 times 10 to the 2 times greater than the area of Rhode Island. What is the approximate area of Alaska? So Alaska is this many times greater than Rhode Island. So we're going to take Rhode Island and multiply it by how many times greater Alaska is. And again, I'll multiply these first numbers. So I'm going to have 1.55 times 4.28. That gives me 6.634 times 10. And I'm going to add these. 3 plus 2 is 5. So 10 to the 5th power. And it says, what is the approximate area of Alaska? They're not asking me to write it in scientific notation, so I'm going to go ahead and convert it to standard form. Remember, when you have a positive exponent, that means this number is going to become very large. We move our decimal to the right. So here's 1, 2, 3. I have to move it 5, so I have to add a couple zeros. So it's 663,400 square miles. We do not put the little square, we don't put the 2 on the number, we put it on the miles. Okay. In 2008, the total trade between the United States and Japan was 2.04 times 10 to the $11. The total trade between the U.S. and Australia was 3.28 times 10 to the $10. How many times greater was the trade with Japan than the trade in Australia? So we're going to put Japan divided by Australia. So 2.04 times 10 to the 11th over 3.28 times 10 to the 10th. And I'll go ahead and divide the 2.04 divided by 3.28. That gives me 0.622 approximately times, and then 10 to the 11th divided by 10 to the 10 is just 10 to the 1st power, or 10. Again, it's not asking me to leave this in scientific notation. So if this is times 10 to the 1st power, I'm moving the decimal over 1, so it's $6.22. How many times greater? $6.22 times greater. Actually, I think we can just go 6.22 times greater. I'm not sure that we need the dollar sign there. Okay, for those of you that want to get started on this assignment, I will go ahead and put it up here for you. This is going to be lesson 3.4 part 1, so we still have addition and subtraction to do. This is page 107 to 108. And it's going to be numbers 4 and 5, and 7 through 10, 13 through 16, 19, 21, 'and we'll call that good for now. So this is part 1.